Good morning, everybody. In this video, I'm going to give you a quick review about the vectors. So here are some of the question, the pre-lab question that you must answer, and the learning outcome of this lab is you should be able to find out the magnitude and direction of a vector. If the magnitude and the angle is given, you should be able to express those in vector terms. Okay, so let's get started. The first thing is, what is a vector quantity? A vector quantity is a quantity that has both magnitude and direction. So it has both magnitude and direction. And what are the examples? The examples are, I'm not going to write down all the answers here, but I'll simply tell you in the words and you should be able to complete this one. The 5 examples of vector quantity. So the examples are, let's say for example, the force is the one example. And if you look at the other example, acceleration, the acceleration due to gravity, electric field, the magnetic field, these are the examples of a vector quantity. What is a scalar quantity? A scalar quantity has only magnitude, not direction. Okay, only magnitude. Let's say for example, the distance. The distance is a scalar quantity. It has only magnitude, not direction. Speed is another example. Work is another example. Power is another example. And then find out the last one. Okay. What is the formula for calculating the magnitude and direction? So here, let's say for example, you are given a vector here. So let's try to understand what does this vector mean here, okay? And then we'll calculate the magnitude and direction. So if I represent any vector on a Cartesian coordinate system, now let's say this is my x-axis, this is my y-axis, and I have 20i. So what does this mean is you have to move 20 units along x-axis. So let's say this is my 20 units. This is 10, this is 10. This is my 20 units here. And then along y-axis I have to move 50 units. So 10, 20, 30, 40, 50, somewhere here. 50. Okay, so if I plot as a point here, so that should be the 20 units along this way and then 50 units along this way. So that is my, so and if I connect to the origin, then this will be my vector. This will be my a vector. Okay, and the reason is it has 20 units along x-axis and 50 units along y-axis. And now once you draw this one, then it becomes much clear to find out the angle and the magnitude. This will be the angle, let's call that is theta, or that we call direction. And how do you find out? So if I look in this case, the tangent theta, then the tangent theta, for example, in this right angle triangle will be the rise over run, or the 50 divided by 20, or in simple words, the y component. Y component, if you are in the vector format, then the y component. What is my y component here? If I look at my y component, that is 50. So this tangent theta is equal to 50, and then my x component is 20. Okay, and from there you should be able to find out the theta, that is tangent inverse 50 divided by 20. And if you have calculator, just plug in your calculator and you should be able to get this one. Okay, and exactly the same way you should be able to solve all the problems. Let me give you another example here so that I feel more comfortable here. Let's say for example, I'm going to do the number d. Here, so on this problem here, you have the 20 units along negative x-axis. So if I call this is my 10, this is my 20, so that is, and then negative 50 along y-axis, 10, 20, 30, 40, 50. So approximately this point. So if I connect this one, then that will be my the vector. Okay, so how do I find out the magnitude? Okay, let's talk about the magnitude and direction for the vectors here. So this is the d vector here, and our a vector was 20i plus 50j. So if you need to find out the magnitude of this vector, that's how I represent, and then this will be simply equal to 20 square plus 50 square. Do your math and you will get your answer. And the same way for this d vector, the magnitude will be negative 20 square plus negative 50 square, and you will get your answer. So that is the magnitude. And now how about the direction? So for the direction of this one, let's find it out. So tangent theta, how do I find out the tangent theta for, or let's call this is my x-axis, so I can call this is my the angle, this theta here. Okay, this theta here. So tangent theta, again remember, this is the y component divided by the x component, so the negative 50 divided by negative 20, and then do your math here. The theta would be tangent inverse negative 50 divided by negative 20. Let me check my calculator, if I have my calculator here. So I can simply plug in calculator or calculator online. Okay, so here, this calculator. So what we have, the tangent inverse. So let's find out how to get the tangent inverse. So if you see here, there should be some inverse here, the inverse. Okay, that's the inverse, and we have tangent inverse, and that here is represented by arctangent. And what are the other quantities? Negative I think 50 divided by negative 50 divided by negative 20, and then close this bracket, and let's express the answer. And make sure that all the answers are in degree. I think I have to redo this one because it was in radian, so make sure that it is in degree. Okay, so let me do one more time here. So first thing is, again, inverse. I'm pressing the degree here just to confirm. So this is in degree. So inverse tangent tangent negative 50 divided by negative 20, and I got 68.19. So about, let's say, 68.2 degree. 68.2 degree here. So we got the angle as a 68.2 degree here, but you see this is much more than this one. So what you're going to see here, so we have to add, so now let's say 68.2 degree on this graph would be somewhere here, no, somewhere like this one, 68.2 degree. So you have to add this angle here, which is 180 degree. So in order to get the correct angle, so in this case the correct angle would be 180 plus 68.2 degree. And how do I know that? Because this is in the third quadrant. Okay, so if your vector lies in this quadrant, you don't have to add anything. If your vector lies in this quadrant, then you have to add 90 degree, and if your vector lies in this quadrant, then you have to add 180 degree. If your vector lies in this quadrant, then you have to use or add 270 degree. Okay, so that's how we find out the magnitude and direction of a vector. Okay, now let's move to another problem here. So in this problem, we given the magnitude and we given the angle here. Oops. So we given the magnitude and we given the angle. Let's try to represent this one in the and find out the magnitude and direction. So if the magnitude, let's say for example, if you have any vector, this is a vector, And if this angle is given, this, let's call this angle A, and this vector is A vector, then your x component here, that we call AX, is always equal to the magnitude, which in this case, let's say for example, is the 5, and this angle cosine 20 degree. And you have to make sure that all the angles are measured with a positive x-axis. And my y component will be the magnitude, which is 5 sine 20 degree. That's the my y component. Okay, so if I see my x component and if I see my y component, then how do I write down in the vector format? My A vector would be 5 cosine 20 I vector plus 5 sine 20 g vector, and all you have to do is plug in the value of cosine 20 and then sine 20, and I will show you one example here. So 5 times cosine 20, this is equal to 4.69 or 4.7. So here is 4.7 I vector, and then same way you should be able to find out 5 sine 20. So here 5 times sine 20, and that is equal to 1.71 j vector. That is my A vector now. Okay, this I unit vector represents, this is along x-axis, and j hat represents the along the y-axis, or the unit vector along y-axis. And exactly the same way you should be able to solve the other problems, and I will show you one more here. Now let's talk about this problem here, the number D. Okay, so if I look the angle, this angle is negative 20 degree. So what does this mean here is, oh, so here this should not be negative here. For some reason I have written down the negative here. It should not be negative, so correct this one. It's a magnitude, so it's just a 5. So it's a negative 20 degrees, so that means this way here, that's the 20 degree. The negative means it is below the x-axis, that's x, and that is y. So sometimes there is a typo, so I think I did a typo here. This is negative 20 degree, so that is how we have. So how do I find out the x and y component here? The x component, as I mentioned before, this will be A cosine 20 degree, and this component will be A, or you can write down negative as well, negative A sine negative 20 degree. The negative here tells you that we are in the fourth quadrant here, okay, or below the x-axis. So A, what is the A here? 5 cosine negative 20 degree, and that is unit vector, plus 5 sine negative 20 degree and j vector, and that is the D vector here. Okay, and then you simply plug in your calculator and get the answer for this one, and you will see this term will be positive and this term will be the negative, which is also very clearly on the graph as well, because this one is positive and the y vector is along the negative. Okay, so based on this idea, just do all your problems, and there is a correction here, there is no negative sign here. Okay, so now let's do this problem here. I'm going to do, I think we already did number A, let's do C here. And how are we going to do that? For this problem, again, the C vector, you can simply write down the magnitude. If you have to represent on the graph, that's the 5 and 220 degrees. So this is 90, this is 180, the total, and then you have to add 140 more degrees. So let's this one, and that's the magnitude here. Okay, that's the C vector. And then how do I find out all the numbers here? Then this number, this x component will be, and this angle So I can write down simply. There are two ways you can solve this one. I'm going to solve you in one way, and then you should be able to find out the other way. So we have the magnitude. So that is 5 cosine. What is this angle here? 220 degree. 220 degree. Because this, if I consider this angle, let's call alpha here, then this component will be c cosine alpha, and my y component here, y component will be c sine alpha here. Okay, but you might be wondering why I use the 220 degree, and but this angle alpha is not 220 degree. So again, if you use alpha, now let's say if you use alpha here, now you'll get the same answer here. The cosine and my alpha in this case is 140 degree here, 40 degree, and I hope you are following me. So because this angle, if you see, this is 180 degree, and so this angle will be 40 degree. If I use this angle, I will still get the answer. Now let me do this one, and then I'll explain. 5 sine 40 degree, because this component will be 40 degree. So what does this mean here? This means whatever the answer I get, I have to add a negative sign here, because I already have identified the vector is in the third quadrant. Okay, so I will get a negative sign. Just plug in this magnitude and you'll get a negative number here, plus whatever this answer you'll get, just plug in. But make sure that as this is in the third quadrant, you see the x component is along negative x-axis and the y component is along negative y-axis, so your answer will be in negative number. But if I use this one, c vector, as a 5 cosine 220 degree plus 5 sine 220 degree, the answer will itself give me the negative number. So let me show you one example here. 5 cosine 220 degree. So 5 times cosine 220, okay, and I'm getting negative 3.83. So write down, you see, negative 3.83, and this would be I vector. You can also write down as a x vector as well, and 5 sine 220. So 5 times sine 220, and I getting negative 3.21. So negative 3.21 j vector, and that's how you find out the vector here. But make sure that you understand things. The negative here means my x component is along negative x-axis, and the negative here means my y component is along y-axis, negative y-axis. Okay, or if you simply take this angle, then you have to add negative sign, because your vector you have to present it is in third quadrant. Okay, all right, so we did this one. Now let's do number 7. Number 7, we have to find out the x component and y component. That is just straightforward here. So in this case, this is my x component. So x component ax will be 20 and my ay will be 50. Okay, and exactly the same way here, my x component will be dx will be negative 20 and my dy will be negative 50. So that's the straightforward. And find the x component and y components of the following vector here. So I think we did this one. This problem and this problem is very, very similar, but let's do it anyway. I think we did this one, but I'll just go over it in case. What we have to find out here is x and y components of the following vectors. So again, is magnitude is given, the angle is given. So first, be clear on your mind how we're going to represent this vector here. So this angle is 20 degrees, so that means this must be in this direction. This angle is 20 degrees, and the magnitude is 5. So this magnitude, this length is 5. So what should be the x component again? This will be my x component and this will be my y component here. And this ax, that we call x component, will be 5 times cosine this angle here, 20 degree. And similarly ay would be 5 times sine 20 degree. Whatever the number you get, you will get your answer. And again, there is a typo here. This should not be negative, it has to be positive. So just do your math exactly the way I did. Now let's do number D one more time. Number D. So dx will be, again, this is just the magnitude, is a 5 cosine negative 20 degree plus 5 sine negative 20 degree. Plug in, and whatever the answer you will get, that will be your answer. I think number 9 we already have covered, but I'll just do in any case. I'm going to do D. Express the following magnitude and angle in vector formats. So let's say, for example, the D. How do I do that? So first, to make you a little bit more clear, I'm going to draw this one on a graph. The angle is 320 degree. So this is 3. So up to this one, this is 270. So I 50 more degree, and that will be this angle here. But if I look at this angle, that should be 40 degree here, right? Because this angle, if you measure in an anti-clockwise direction, so this angle is 320 degree and this angle is 40 degree. Okay, so, and this magnitude is 5. So now there are two ways you can solve this one. So the one way is, I have represented my vector and I see that this is in my fourth quadrant. So in fourth quadrant, I can clearly see my x component is positive and my y component is negative. Okay, so what does this mean is my dx component would be this 5 times cosine. If I simply write down 320 degree, I'll get my answer, plus 5 sine 320 degree. Okay, if you plug in, you'll get the answer. And the other way is if I write down dx is equal to 5, and if I use this angle, cosine 40 degree plus 5 sine 40 degree, then I must use the direction as well, because the 40 degree could be along this way too. Okay, so then I have to specify this, that the vector lies in the fourth quadrant, and the way I do that I must plug the negative sign here, because this is below the negative, this is below the x-axis. Okay, so that way in either case you will get the same answer. All right, but make sure that you understand these things, convince yourself that you understood these things. Okay, now the last one, we have to represent these vectors on a graph. This is very straightforward, 20i plus 50j. So this is, if I consider this is 10, this is 20, and this is 1 2 3 4 5. So somewhere this point, this will be my 20a, this is my 20i, oh sorry, this is my 20i, and this is 50j. So this will be my a vector. Okay, now if I consider the c vector, that is, what is this, tell you 20 units, and negative, this is negative here, so I have to go down. So that means this will be my negative, this will be my c vector, and this will be a vector. And similarly, you should be able to plot the vectors. So this is it from this video. If you have any other question, any confusion, try to find out answer by yourself, and if you cannot, then write down in the comment section below or ask me the question. Thank you very much and have a wonderful time.